Hi, today I'm gonna be modding this GPU. It's a GTX670 from Asus. It's a DirectCU2 top. This PCB is pretty much one of the best PCBs you can get with a 670, except for Galax and I believe Zotac. However, those are rather hard to find compared to Asus cards. So I got this one. And what I'm gonna be doing today is basically preparing it for overclocking. And yes, for once I'm not gonna be repairing anything because this GPU actually works, so hopefully I don't break it. Perfect, nobody was in here before me, since you can see the factory paste. Okay, so here's the GPU, cooler can go away. And do I need to remove the backplate? Actually I do. Okay. Now that we have disassembled the GPU, we can have a look around the PCB, what's where, and how is it assembled. So here we have our controller for VRM, for the vCore. Here we have controller for the VMEM, and this one I believe should be PEX. And first things first, we need to do on a GPU which has power limit is that we remove it, because we don't want any of that while overclocking. And on older GPUs like this one, you can simply, you can actually do multiple things. First, you can modify the BIOS on this GPU and raise the power limit to bejesus, let's say 1000 watts, and we are good to go. The GPU will not be throttling anymore. However, I'm not a fan of that because it's boring. Second option we have, which is fairly well known. You can short these shunts with soldering iron. Once you short them, the GPU is gonna have skewed readout. And to be honest, I also don't like this option because soldering on shunts is boring. Come on. So another option we have is removing the sensing IC or the controller for it. If we have INA3221 sensing IC, which would be normally here, in that case what we do is simply desolder it, and the GPU loses all power limit because it cannot read the power anymore. But since this GPU doesn't have it, it's using different approach or different IC, and in our case it's these two fuckers. It's INA 219s. And these things do exactly the same thing like INA3221, where basically they sense the difference between input and output side of the shunt and calculate the voltage drop, and that way they can tell how much current is going through them. And then they send the readout or the data value back to GPU through I2C bus. And what I found out, you cannot remove these INA 219s, otherwise the GPU will not boost. Interesting, huh? Yeah, it just refuses to boost when it doesn't get some sort of I2C response from these ICs, but even if the ICs don't read anything, it will be fine. Which is the fun part about it, so we actually don't need to touch the shunts even, we will be messing with these little ICs. Let's switch to microscope so you can see better. Now that we see a little bit better, we will be looking for the first pin on these ICs, which is marked by this dot and this dot on the PCB. And this dot, now we know that this pin is number 1. And this one is number 2, and so on. And these two pins are actually the sensing pins that are sensing the voltage difference between the input and output side of the shunt resistor here. So what we do is simply short these two pins together. What you can also do is simply remove this capacitor and put a short in between the pads, and you'll be fine as well. However, to me it's gonna be easier just to solder on top of these legs, short them together, and that way there will be no voltage difference read out, and as such the GPU will be sensing 0. Let's do that. Let's fire the soldering iron up. A little bit of flux. Good. Solder. Perfect. That was easy. Perfect. All right. So that is the whole power mod. It was fairly simple, as you can see, and we can continue now that we have deleted power limits. And second thing we're gonna do is have a look at the VRM controller for the vCore. And sadly, you cannot read the chip. Let me tilt it a little. Yeah, now you can. So as you can see, it's ASP1212, like I mentioned before. And here we have these three lovely pads for a jumper. And these three pads are obviously for I2C bus. So what we're gonna do is simply control the VRM controller digitally through EVC. Also, in theory, you can also have a regular feedback mode on this GPU, but it is not as simple. Reason is that the pin that is sensing the voltage on this controller, it's actually pin number 4, so this one, this trace, is directly hooked up to the VRM output. So there is no resistance in between nor a resistor, which means we cannot simply lower the resistance towards ground to sync the voltage because it's not gonna work with that trimmer. So what we would have to do here is actually go on follow this trace, and right here where you see the via, behind this via, in between this capacitor, we would need to cut this trace. Now that we have severed the trace, this one will be floating, so it's disconnected technically. Next, what we would have to do is take a 100K resistor and connect that 100K resistor between this pin and ground. Any ground it will do. And then, on top of that, we also take 10,000 ohm resistor, or 10K, variable resistor, or potentiometer, however you like. And we will connect one pin of that variable resistor to the same point we connected the 100K resistor from ground. And second pin of that variable resistor, we would have to connect to the VRM output. So in our case, probably this spot, since it's the closest plus. And that way you would have regular feedback mode with regular potentiometer where you just turn and adjust the value. That way you also influence the voltage. As you can imagine, it is kind of annoying to do because you need to cut traces, you need to do this voltage divider. It's generally pretty annoying process to do. So since I have EVC, I'm just gonna do it via I2C. And in order to see which pin is which, well, use multimeter. Hopefully you can see it. Yes, you can. Now let's figure out which pin is which for I2C. So let's check for ground. Okay, this one is ground. Second, we need to figure out which is which. And that should connect to pin either 16 or 17 on the controller. Let me see. Oh, you cannot see. Yes, okay, so this is pin number 17. It's connected to the middle pad, and pin number 17 is clock. Okay, so the last pin is data. And if we look at EVC, we see that here we have clock on this side and data in the middle. So we need to switch these two around against EVC. So basically we switch data and clock compared to the layout of EVC. Now that the VRM for vCore is Dunsky, well, hooked up for I2C, we don't really need to do anything else because we can digitally control not only the voltage output but also the overcurrent protection. So normally, if we did hardware mod, so we would be doing the feedback mode like I described earlier. In that case, we would possibly need also OCP mod eventually in order for the VRM not to trip when the GPU is overclocked hard enough. However, we can set it digitally, so there is nothing else we need to do with this controller. So we move on to memory. So here's our VMEM controller. It's UP1631P, and this IC is really annoying because there is no datasheet for it publicly available. And luckily, I have board view with this controller, so it wasn't too hard to figure out which pin is what. I'm gonna give you a screenshot of that. And in our case, pin number 14 is the pin we are looking for. So here is dot. So pin number 1 is this, 7 and 14. So this is our 14 pin. That should be our feedback. And we look against the ground for resistance. 750 ohms. Okay. Check also against the VRM output. 720 ohms. Perfect. So we need basically, since this is barely 1k resistance, the rule of thumb is you use 10 times as high value for potentiometer than your feedback is. So in our case, ideal would be like 7.5 thousand ohms to 10k. Since 7.5k trimmers don't exist as far as I know, we simply use 10k one, so that's it, and we just connect it to ground. And before we do that, obviously we need to find some suitable spot because, well, soldering directly onto the controller pin is pretty annoying. So let's see if we have some component next to it that's connected directly. No. 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 Okay, perfect. So this one is directly connected. Yeah, okay, this is pretty large resistor as well, so we can easily solder on top of this. Okay, let's do that. Hmm. Okay, pretend, and let's put on the wire. What I'm using here is enameled wire. The thickness I don't know because I simply stole it from a PSU transformer. Perfect. I found the potentiometer, stole it from a GPU, and it had a switch conveniently, so perfect. And while I was at it, I was actually thinking also where do I put it, and came to conclusion I'm gonna probably place it somewhere here. So hopefully I can still put the stock heatsink on without it being in the way. Maybe, maybe not. Worst case, we'll just nibble out from the heatsink. That's fine. And also I have pretty convenient ground right there because as you can see, this middle big pad from the missing controller is actually ground, or should be. So let's double check. Ta, 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 ta. Yeah, of course it's ground. I just have really bad contact. Okay, so yeah, we'll use that for ground. And in order to fix the potentiometer in place, I'm gonna use cyanoacrylate glue. You can also use hot snot, but I don't like hot snot because if the GPU remains on air cooling, it's gonna get hot and it's gonna get melty and blah, Jesus fuck, not again. Oh, there, it's the liquid. Perfect. That's a bit much. Well, I guess I'm gonna have stuck together fingers again. Not sure if I need more heat or it's soldered, because I'm not looking through a microscope for once. Let's see. Yeah, it's all lit perfect. Next is hooking up this wire. Yeah, mechanical scraping it first is not a bad idea at all. Uh, I'm just lazy. Flux. I don't want these solder spikes. Okay. No. Not okay. Okay. So, volt mode Dansky. And one last thing you might want is some voltage sense, so you're actually able to probe what voltage is the VM outputting. And for this, I don't really see too many good spots, except for the capacitors. Well, I guess I'm gonna just use the output capacitors. And yeah, let me replace the soldering iron tip for a different one. It's more suitable. Ideally, something like this. Some flux. And yeah, first thing you wanna mix up some of leaded solder with the lead-free stuff because it has lower melting point, so it's gonna be easier to work with. Okay. And in my case, since I'm lazy, I'm gonna steal one more thing from another GPU, and that's our voltage sensing thingy, aka Molex. Okay, so ground goes here. I could use some thinner wires, blah blah blah, to make it prettier, but I don't care. Okay, positive. Perfect. Alright. So we have VMem control, we have vCore control. Let's plug it into the system and see if she runs. Last step before we can start benching is detecting the controller by EVC. The thing is, ASP1212 or CHL8318 does not get auto-detected by EVC. Let's see. Yeah, find devices, and it finds, well, everything but also nothing. and the software crashes afterwards. So let's make a workaround. Software is restarted, and now what we do is choose from our profiles CHL8318, and we also need to find the address. As you can see, we have a couple options here. In my case, I believe it should be address number 72. Let's add it and check. We click on monitoring, and if it monitors, then it's correct address. And it doesn't monitor anything, so it's probably not our correct address. Okay, let's try address 74, add, monitoring. Here it is monitoring, so perfect. And now that we have monitoring working, we know that our address is number 74, not 72. I was mistaken, or my other GPU actually needs a different address than this one. Anyway, here we have, let's unclick confirm, so that way we don't have to confirm every single hex value that's being changed. We enable the gamer mode, and we have already override, so that's perfect. And here we have gamer voltage. So in this dropdown, you simply select voltage you want. Let's do 1.2 volts in my case. And we hit apply. And we have 1.2 volts. As easy as that. So just don't forget, you need to add it manually. Happy benching. Bye.